Okay, so we collected data with this spectrometer on a client device. We identified a peak here around 385 nanometers of a trace gas, and we needed to quantify the levels of that gas. After a little bit of literature research, we were able to identify that peak here around 385, and found an analog sensor that we could use to essentially characterize the levels of this trace gas from this device. The problem, though, is that this analog sensor is highly dependent on temperature, and so we essentially created this setup specific to the customer. We've got a Raspberry Pi here. This is a Texas Instruments evaluation board to help process the analog signal. We've got this ADC breakout just to make sure that we can get it over to the Raspberry Pi. So again, application specific, but able to characterize the response from this gas sensor so that we can quantify the trace gas levels coming from the client's device. All right, wanted to just talk a little bit about the fixture here. Fiber infused nylon essentially, but this fixture is just part of what we provide for test services. Essentially make sure everything is fixed. Goes along with prototyping services for different electronics, different test configurations. And in this case, forgot to mention there's also an included temperature and relative humidity sensor to help correlate the temperature to the analog sensor. Now, another reason for the carbon fiber infused nylon is that the testing was done inside this temperature chamber. And there's a situation where the temperature actually reaches above, close to 120 C. And so I initially had done this with PLA, but that obviously didn't cut it. I wasn't expecting the temperature to get that high. That's why I initially went with PLA. So went with carbon fiber infused nylon, more than suitable for the temperature that we needed to reach on another test. However, we ended up being able to modify the requirements, configurations of the test chamber so that we could only needed to go up to 50 C. Okay, now this fixture just makes it a lot easier to place inside. We route any cabling, really just power through here, and we can monitor that. In this case, we did a 24-hour run. So super useful. We can set temperature here. Just have this to be able to kind of monitor where we're at environmentally. And so far, this is just increase in temperature. We don't have relative humidity control, but it's something we're adding on to our offering for any test services. Here we have a temperature, relative humidity, and trace gas concentration trace. Just went ahead and blocked this out for confidentiality reasons, but so I'll explain this. Essentially, the concentration of the gas sensor is held constant, and really just changing the temperature of the temperature chamber that I just showed. And this is what allows us to then calculate what the correction relationship is, and allows us to essentially establish what the uncertainty measurements are for a baseline measurement of the gas sensor. This lasted about 24 hours. let the temperature rise to about a little over 50, about 56 degrees Celsius, and then turn off the temperature chamber and just let it come down to room temperature. Essentially, over this test, we're just trying to gather data across from about 30 C all the way up to 50 C. Went up a little bit just to kind of cover our bases. And this allowed us to establish that correction factor, correction formulation, and to quantify the uncertainty of the gas sensor. Here's just an example of the sensor characterization certificate report that we issue. We have a sensor under examination, provides serial number or part number depending on trackability or traceability. Purpose is really just a summary of what we're doing, type of characterization. Method and equipment just describes the equipment that was used for the characterization. And the first page of this certificate just provides very brief results highlight, kind of just a quick summary of the main point of the main purpose of the test. And this particular test, it was a data correction function. It was linear in this case, and it gives you a mole fraction based on a temperature value. Allows you to correct the signal based on measured temperature of the sensor. And it also provides here, as you can see, an uncertainty measurement that's explained in more detail in the follow-on pages of the report, but is provided as a highlight here on the first page. And then just a signature, test engineer information on the front page. So that's basically the overall structure of our gas sensor characterization certificate. If you need any help with gas sensor characterization, testing, overall design, please reach out. Use the link for a free phone call.